Dr. Babasaheb Ambedkar Open University.
Hello students, welcome to the lecture series of the subject Cloud Infrastructure and Services. In previous session, we have started Unit 2, in which we have discussed cloud architecture. You can specifically say that cloud layer architecture. We have discussed 4 different layers and the role of different layers in this cloud architecture. We have also discussed in detail peer-to-peer architecture as well as client-server architecture in detail. We have also compared both these architecture. Now move ahead in this unit. The next topic that is most important we will discuss in this unit. So today's agenda, we will discuss the fundamentals of grid computing. Then after, we will take the difference of grid computing and the cloud computing. Then after, the very important feature of cloud computing, that is server virtualization and its types, that we will see in today's session. Now after completion of this session, you will able to understand the basics of grid computing. You can explore the key differences between grid computing and cloud computing, and you can exploit the advantages of virtualization, or specifically you can say that the server virtualization and its type. Now starts with the grid computing. So first of all, what is grid computing? So grid computing is a computing infrastructure that combines computer resources spread over different geographical locations to achieve a common goal. You can observe in the figure, say for example, you are requiring to access multiple resources and somehow or in some way, suppose not all the resources are utilized. In that case, what happened? You are collecting all those unutilized resources combined together and you can perform some task with some free resource available. So that is the main fundamental of grid computing. So all unused resources on multiple computers are pulled together and made available for a single task. Now organizations use grid computing to perform large tasks to solve complex problems. What happens? Suppose you want to perform any complex task. In that case, it is not possible to perform with a single computer, single machine or single infrastructure. In that case, you have to divide your task into multiple small tasks and you have to assign each and every task to individual machine or to some individual infrastructure. Then after at the end, you are combining the result of all those infrastructure, all those services, and you can generate the output. So instead of being located in the same place and working together on a single massive task, the grid divides a large workload into smaller pieces as we have discussed. With each, this cloud computer contributes its ideal resources to complete these small jobs, making it ideal for scientific research, weather modeling and complex data analysis. So these are the examples by which you can use the grid computing. Now it is also considered as a subset of distributed computing, as we have discussed. In distributed computing, basically whatever the resources that are distributed, so how it works? First of all, resource pooling. So unused computing resources such as processing power or storage from many different computers that can be pulled together. That is the main fundamental of grid computing, because you are using some unallocated resources and you are pulled those resources for your task or for your use. Now task distribution. So central control node, or you can say that the controlling system that divides a large complex task into smaller independent tasks. So here what happened? Because you are using different location resources, in that case what happened? You have to manage first of all whatever your task that you want to complete, as well as you have to manage whatever the pulled resources. So that is the task of the control server that can manage all these tasks. Next is network connections. So these distributed computers are connected via networks, obviously, because you are using different resources from different locations, different nodes, different computers with the help of internet to allow communicate and the task assignment. Fourth one is middleware. It is the specialized software, you can say that the middleware manages the coordination of these various resources and the task. So one thing that you should keep in mind, in grid computing, basically your complex task that is divided into multiple small tasks, and the second is resources that you are pulling that may be or that can be managed properly. So this thing that can be done by the control node, and middleware, that is the responsible software that can be helped to manage all this. Then after problem solving, so whatever the small task that can be solved for different pool devices, and ultimately the result you are combining and generate the final result. This way you can solve the problem. Now grid computing network comprises of three types of machines of the network. Control node or servers, as we have discussed, a server or a group of server that administers the entire network and maintains the record for resources in the network pool, because management of resource is more important in the grid computing, because you are using whatever the unallocated or unused resources at your end, right? So the management, it is important, that can be managed by the control node. Then after second is provider or the grid node, a computer that contributes its resources to the network resource pool. So here suppose, say for example, the 50% of that particular utilization that is free, in that case that 50% that will be allocated to which require or which person or which device that requires that particular system. In that case, whatever the provider, that will be considering as grid node. And then third one is the user, that refers to the computer that uses the resources on the network to complete the task. Then real world example, so you can imagine the university research team. Now say for example, that team requires to analyze million of images. So it is not feasible to analyze that million of images on a single computer. Rather than you are dividing your task into some small task. Say for example, all those images you are dividing into some bunch of images, say for example 1000 images of that particular bunch, and all the images, those bunch, that can be accessed or analyzed by the different resources that you have pulled, right? So ultimately what happened, the task that is faster, and ultimately the result that you are getting from all those different nodes that you are combining together, and you will finally generate the result. So research team will compile the result after completion of individual subtasks that will be completed. So this way the grid computing will work. You can take another example. Say for example, here suppose you are requiring for weather forecasting, and your system is divided or that can be spread on different regions. So what happened, that particular regions, your system that will take the data, and at the central location all those data are compiled, and generally you will find out the result of all different regions. So the weather forecasters or weather modeling, that can also use this architecture. Now we will take the difference of grid computing as well as the cloud computing. So majorly grid computing, that is the distributed resources, as we have already discussed, because whatever the resources that are not allocated, that you have to pull. So that distributed resources that used in the grid computing, while in the cloud computing it is on demand resources. As we have discussed in the previous session, that according to your requirement you are demanding those resources, you are demanding those services, and for only those you have to pay. So here it is on demand resource or pay as you use, that model that can be used in cloud computing. In grid computing, resource sharing that can be done, because you are pulling those resources, and here in cloud computing the resources are pulling, you can say that particular user having their own pooled resources, while here in the grid computing whatever the resources that can be shareable among multiple users. Another difference, that is task oriented. So the ultimate thing is that in grid computing your complex task that is divided into smaller tasks, and at the end you will get, or you have to combine the result. But in cloud computing it is service oriented. Whatever the requirement of service is, accordingly you have to use only those detail, you have to use only those platform or the service. Now in detail you can observe application focuses, that is business and web based application in cloud computing, and in grid computing it is collaborative purpose obviously that you are using. In architecture used, so it is client server for cloud computing, and for grid computing it is distributed. Management, that is centralized in cloud computing, while in grid computing it is decentralized. Business model, as we have already discussed, pay per use, while in grid computing no defined business model is there. Accessibility of services, it is high because it is real time, and in grid computing it is low because it is scheduled services. Programming models, there are multiple examples available. OpenStack for infrastructure as a service, there is no middleware exist, while in grid computing different middlewares are available such as Unicore, that is the example. Resource usage pattern, that is centralized manner, and in grid computing it is collaborative manner because you have to pull, you are requiring multiple resources from various locations from different providers or the providers. So collaborative manner operations will be performed. Flexibility is high in the cloud computing, while in grid computing it is low because as ultimately it is the distributed computing and you have to depend on that particular resources. Then interoperability, that is vendor lock-in and integration are some issues, while in grid computing easily deals with interoperability between the providers because whatever the requirement that is available with the vendor, so you can log this and you can use according to your requirement, while in the grid computing always it is required to find some better option. So this is the basic difference between grid and cloud computing. Now the server virtualization, you already aware with the concept of virtualization. In the previous session we have taken one example. Suppose in your system you are running Windows, now you are requiring some Ubuntu or Linux operating system or Mac operating system. So you are having one alternative, you can buy the new system, whole new system which contains the Mac or which contains Ubuntu or Linux. Rather another alternative is that you are using the concept of virtualization in which whatever the hardwares that you are using that is same, but the operating system that you can manage with the help of virtualization platform. So here it is very effective, cost effective manner. So this concept that can be used here also in server virtualization. So if this concept is used in server, that is considering as server virtualization. So basically server virtualization lets you run multiple isolated virtual machines. Whatever the virtual machines that you are created, they are working as isolated, and whenever the user will use those machines or virtual machines, they are in the illusion that whatever the hardware or the resources related with that virtual machine, they are the owner of that machines because the virtual machines are separated according to the user. In that virtual machine, separate operating system, separate memory, separate CPU, separate storage, all are possible in single virtual machine. Why it matters? Because consolidation and cost saving, obviously you don't have to buy another resources, you can just use the resources by using the virtualization concept. Agility, so provision servers in minutes, clone, snapshot and rollback easily. In cases some of the fault that will occur, in that case simply you can switch between the devices, between the services. So agility, that is the important feature here. High availability and mobility, so move running virtual machines between hosts, recover from failure faster. Better utilization, push hardware towards 60 to 80%. Obviously, why it is better utilized? Because not any system that is 100% utilized. So if you are running your system and your system is allocated only 20-30%, then the rest that are wastage. So if you don't want to waste that particular utilization of processing power or the memory power, you can use virtualization concept and you can use some another task, you can run some another system on the same devices. Here you can observe in the figure, if you are not using that server virtualization and if you want to use 3 different apps, so you are requiring 3 different servers. Say for example, I would like to use, say for example, Facebook application, I would like to use any game application, I would like to use any bank application. So all 3 applications which requires 3 different servers. So server here cost that will be increased. But if you are using server virtualization, in that case what happen, your server itself that can be virtualized and different applications that can be successfully execute on a single server without paying for different servers. Then how server virtualization works? So you can observe in the figure, basically layers are there, hardware layer at the bottom, then after hypervisor, and different virtual machines are there. So if you want to access whatever the available hardware, or you can say that the limited hardware, and you want to run different software, you want to run different systems on that particular single hardware or the sufficient hardware, then there is a layer called hypervisor, or you can say that it is the middleware by which you can access, you can utilize all those hardware with the help of the software called virtual machine. So multiple virtual machines that you can create, whatever number of virtual machines you can create, accordingly separate memory, separate processing power, separate storage that will be allocated, that will be defined to the user. So you can say these are the different things, physical server, that is the host. Then after the original powerful physical computers that provides underlying hardware resources. Yes, obviously whatever the hardware that you are using, that must be with high configuration. Then hypervisor, that is the software that sits between the hardware as well as whatever the virtual machine platform. Then after virtual machines, so virtual machine is a software that deal with the hypervisor, that is the middleware platform, and interact with the hardware, and it will provide the illusion to the user that user itself having his or her own memory, his or her own processing power. That is the task of virtual machine. And the guest OS, that means whatever the operating system the end user will work upon, say for example Windows, say for example Mac or Ubuntu or any other operating system. Now we will see different types of server virtualization, that is the important concept. So basically it is broadly categorized into 3: full virtualization, para virtualization, and third one is OS level virtualization. The same concept in the previous slide that we have discussed, that you can observe here in the figure. At the end, hardware level is there, very high configuration hardware that is available. You can use hypervisor, that is the middleware, for interacting with different virtual machine, and user or end user that interact with that virtual machines. Now these types we can see with the example: hosting multiple website on a physical machine, that is shared hosting. If you want to host your multiple application on a single server, then it can be possible with that server virtualization. Now running multiple operating system, as we have discussed, that is the very common example, that is also available with this server virtualization. Now different types we will focus in detail. Full virtualization, so what happened here? The hypervisor completely emulates the underlying hardware. Each virtual machine thinks it has its own physical machine. So end user cannot identify he or she will work on the virtualized machine. He or she has illusion that they are having separate resources, their own resources they are working upon. So that is the beauty of full virtualization. Here you can run any operating system. It is not required to modify the operating system. Example: VMware Workstation, Microsoft Virtual Server. These are the example by which you can use that virtual machine concept. In real life analogy, you can say that the like building a virtual city inside a video game, where every house, you can say that the virtual machine believes it is the real building. Second one is para virtualization. Guest OS is aware it's virtualized and communicates directly with hypervisor through special APIs. What is the difference between full virtualization and the para virtualization? In full virtualization, we have seen that the user or the end user don't have any kind of illusion that they are using the platform called virtualization. But here in para virtualization, the special APIs that can be used by the hypervisor and the guest OS or the end user can understand he or she will be working on particular hypervisor platform or the virtualization platform. So here it requires the modification of operating system. In full virtualization it is not required. The example is Zen hypervisor. The real life example like roommates that shared Wi-Fi or shared the kitchen, but they are smoothly managed, they are coordinating the same thing that is done here while using the resources in this para virtualization system. OS level virtualization, that is nothing but the concept your operating system that can be divides or that can be virtualized among multiple users. Here no hypervisor, the role of hypervisor is nothing here. Instead of that hypervisor, the operating system allows multiple isolated users. So say for example multi-user system, you can say that. So every time the user logs in, accordingly the role will be defined. So here it is the level at operating system, not the hypervisor level. Example is Docker. Each dock having its own operating system part. Analogy, that is like multiple apps on your phone that can share the same OS but run separately. So every user can work independently on a single system, but the operating system or multiple users without the use of hypervisor. Hardware assisted virtualization, that is the next type, use special CPU feature. Now what is the difference? In previous case, your operating system platform that is divided among multiple users, while here whatever the hardware, especially the CPU that are specially designed for that particular functionality, that Intel VTX, AMD, these are the special CPU, they are improve the virtualization efficiency in which the multiple user can use the single CPU, but they are understanding, they are illusion like they are using the separate processing power if they are using that hardware assisted virtualization. Example VMware ESXi, Microsoft Hyper-V, these are the platform in which your CPU that is divided and it combines the performance of para virtualization with compatibility of full virtualization. Like cars designated with special lane on highway, faster and smoother. So this is the real life example. The last type is hybrid virtualization. It is mix of full virtualization plus para virtualization. Here some part of OS are modified to talk to the hypervisor while others are full emulation. So as we have discussed in operating system virtualization, in which operating system will be divided among multiple users, but here in the hybrid virtualization some of the part of operating system that are divided among the user while some part that are using the hypervisor. So here the mixed concept that is used, that is full virtualization as well as para virtualization. So modern version of Zen KVM. So real life example like having both private shortcut you can use on the highway as well as the public road you are using whichever is the faster. So you can get benefits of both the platforms, that is para virtualization as well as full virtualization in the hybrid virtualization. Now let us sum up. We are concluding our session here. In this session we have discussed the concept of grid computing, which concept that is used for implementation of grid computing we have already discussed. The basic difference between grid computing as well as the cloud computing, and the most important concept of cloud infrastructure, that is the server virtualization by which we are using or various services as well as multiple platforms among different users with the help of this cloud computing services. So this server virtualization concept and its type that we have also discussed. Thank you for this session. In the next session we are coming up with other features of cloud computing. Till then, happy learning. Thank you.